Hi guys, welcome back to my channel Programming with Pirai. In this video, we are going to see about a question called top view of binary tree. So they will be giving a binary tree and we want to give a top view. That is what? When we are seeing from a top, what are the nodes is visible to us. So that should be a output. Okay, so let us consider this binary tree and I am seeing from the top. When I am seeing from top, first of all, this 25 is visible, right? Okay, this 22 is visible. Because of this 22, my 15 is not visible, right? This 22 will block 15, right? Okay, when I am seeing from this 20 will block this 3 as well as this 4. Simple, right? Because these two are lying in the same position and also 20 is above them. So I can see only this 20 and these two are invisible to me, right? And then when I'm seeing here, I can see this 8 and I cannot see this 10, right? Okay, when I'm seeing here, I can see this 5, I cannot see anything else because there is nothing, right? Okay, so I can see only what? 5, then 8, then 20, then 22, then 25. So this should be my output, right? Can you understand this? Okay, can you observe this? It is like a vertical line. Here, one vertical line, here, here, here. So this is the observation, right? Okay, so I can say in each vertical lines, which node occurs first is the node that is visible to me. See here, what are the node occurs first? This 5 occurs first in the first line, this 8 occurs first in this line, and this 20 occurs first. Then here, this 22 occurs first. Here, this 25 occurs first. So from this, I can say whichever the node that occurs first is my answer, right? Can you understand this? So this is my output and this is my approach also. So I can say I want to keep a level like this. Okay, first of all, I keeping a level like this. Okay, now tell me in this level, just take for example this 0, it is 1, it is 2, and it is 3. So I can say 0, 1, 2, 3. Now I can say if see here, take for example this line, in this line, I can say 20, 3 and 4 are lying, right? But whether 2 is smaller or 0 is smaller, I can say 0 is smaller. So I want to take what? Level 0. I want to take the level 0's answer. So this 20 is my answer, right? So we compared the levels to achieve what? Which node comes first. Can you understand this? So I can say the node with level, a minimum level, the node with minimum level should come first. So this is my observation, right? Okay, fine. Now, to do a level, to go by level, we do what? A level order traversal. So we also find out what? It is a bus traversal. Okay, fine. Now, how can I represent this lines? So in normal graphs, we represent like what? 0, -1, here 1, here -2, here 2, like that. Can you understand this? The root will be what? 0, and the roots left will be what? 0 minus 1 is equal to -1, and roots right is what? 0 plus 1 is equal to 1, and this -1's right is left is what? -1 minus 1 is equal to -2. Here it is 2, like that. Okay, now we can go with further example. See here, this is my example, right? Now we are going to do what? A level order traversal for this. A level order traversal. So to do the level order traversal, what is the first thing? We want to take a queue, right? Okay, I taking a lengthy queue. Now, initially, what is my roots position is 0. The line is 0. Okay, so I push what? 20 and also 0. So this should be the first value in my queue. Now, take for example, we want to take the each and every value and store in a resultant array, right? We want to store in a result. So I can say to take each and every lines, I want to store them in some data structure, right? So I will take a hash map in which we can use a key and also value, right? And I will use that level or line as a key, and I will use the value as our result. The top view, right? And also in question they were given that if two nodes are at same position, then we want to take what? We want to take the leftmost node. So in normal BFS, the leftmost node will be the first, right? So we can ignore that. The condition is we then the condition is the condition is already satisfied. Okay, now first of all, I took this 20. Now what should I do? I should pop this 20 out, right? Okay, I'm popping this 20 out. Fine. Now what are the child of this 20? I can say the left child is 8. So the left child position is what? -1, 0 -1, right? And right side position is what? 1. Yes, and this 20 is back at the line 0. So put line, and also what is the value? It is 20. Yes, now I will pop this 8 outside. Okay, while popping this 8 outside, I want to take care of what? Take care of its child, right? Okay, what is the left child? I can say 5 is the left child, and also 2 a -1, so -2. Okay, now what is the right child? I can say right child is 3. Okay, do +1. So +1 will be what? -1 + 1 is 0. Can you understand this? Okay, fine. Now this 8 is a value, and what is the line? It is -1. So put 8. Now pop this 22. Now this 22 line is what? 1. Okay. First of all, we can just put the child first. So what is the child? The left child is 4, and it should be -1, right? So +1 -1 is 0, and it has a right child. It's 25. So 25. So +1 + 1 is 2. Can you understand this? Okay. Now 22 is at the first line. So put 1 and put 22. Now pop this 5. Say. Okay, so 5 line is what? -1. It doesn't have any children, right? So I don't want to include anything. That we put what? -2 and 5. Okay, I'm popping this 3 outside. So 3's value is 0. Understand this carefully. 3's value is 0. And also, what I have in my data structure, I have 0 already. So I don't want to update it, which means what? I already found in a better level. So now you cannot update it. So leave it as it is. Okay, what is the children of this 3? I can say 10. So 10 is the left child, right? So 10, 0 -1, it is -1. Hope you understand this. Now, if you want to pop this 4 outside, okay, for this 4, I can say it is also 0, so I don't want to include it. Okay, now, what is the child? It is 15. 15 is the right side. So 15, 1. Yes, now again. Now I want to pop this 25 outside. Okay, 25 is what? A leaf node, so that's why it doesn't have any child. Okay, now, what is the 25's line? It is 2. So put 2 and put what? 25. Now, pop this 10 outside. Okay, 10 doesn't have any child, and also -1. So -1, we already updated it. So we don't want to do anything. Okay, now pop this 15 outside. So 15 is what? It doesn't have any children, and its line is what? 1. But 1 is already exists, so we don't want to do anything. So just pop it out. Now the queue become what? The queue become empty. So I want to stop here. So this is stopping point. So at last, what is our data structure value? It is something like this. Now, we want from -2 to +2, right? We want in order like what? First -2's value, then -1, then 0, then 1, then 2. It is from left to right. We want the values from what? Left to right, this way. So I can see first this 5, then this 8, then this 20, then this 22, then this 25. So I can use what? I can make use of what? The minimum maximum value. So minimum value in dictionary key. And also the maximum value. We want to find the min and max. And I want to traverse from min to max. Right? And store each and every in my resultant array. Just append it. In my resultant array. Can you understand this? Okay. What is the time constant space something for this solution? I can say my time constant will be O of n because I'm iterating each and every node. Right? Now, what is my space complexity? I can say space complexity will be O of, say, I have different levels, right? In different levels, we have a different node. So, at the max, what is my maximum node in each level? It may space complexity, so max of level node, right? So, what that signifies? It signifies that, see here, take further example, in this binary, I can say at the most our queue have 4 values. Other than that, we have either 3, 2, like that. At the most, it have the 4 values in our queue, right? So that's our space complexity. So this is our timer space complexity analysis. Now let us see this code here. First of all, dictionary is equal to empty dictionary. Now I'm putting a queue like what? A root, 0. Now start and end is what? Float of infinity and float of -infinity. There we put what? We separately finding the minimum maximum value, right? Instead of that, we can find like this also. So that's why I included this. So while there is an element inside the queue, I want to put what? node comma line is equal to queue.pop of 0. So I'm popping the front value. Now, if line not in the D, then what should I do? D of line is equal to node.data. So if that doesn't exist, then only I want to put. It already exists, I don't want to update. That's a better answer I got. That's a top view answer, right? Now, if I have a left child, just append the left child by doing what? Line minus 1. If there is a right child, append the right child to what? Line plus 1. And the start is equal to min of line comma start, which means what? We are taking the minimum value in the line, which means what? Minus 2 is a minimum value, right? So beyond the updation, by doing the continuous updation, we can get the start and also n is equal to what? Maximum. So I will get the maximum also. Now, resultant array. Now for I in range of what? Start to end. And if I is in D, then only I want to do what? I want to include that into a result. Right? Then I am just returning what? This is the result. Let me submit it. Yes, it is submitted successfully. Thank you.
And then the other, I'm a dog nom.